All right, well, welcome back, and we're going to be talking about 7.1. We're on day 1, and we are doing some sampling distributions. And what we have here is an example. This is our actually example number 2 of some sampling distributions. And here we have a James family, has 5 children. Jocelyn, age 8, Elise, age 8, Michael, age 14, Erica, age 16, and Sarah, age 18. Now, what I want to do is we want to complete the table by listing the 10 possible samples of size n for the population and calculate the sample mean age for each sample. First column is completed for you. All right, so here we go. We have J and A, so we'll call this J, we'll call this A, we'll call Michael M, E for Erica, and S for there. All right, so James, if you see that right there. All right, so we have JA is 8. Now our next mean is going to be JM, all right, JM, and that's going to be 8 plus, all right, 8 plus 14, and we'll divide that by 2, and we get 11. All right, then we're going to go J and E, James and or Jocelyn and Erica, and so we have 8 plus 16, and then we'll divide that by 2. We have 12. All right, we're going to go James and Sarah. All right, or Jocelyn and Sarah. So we have 8 plus Sarah, which is 18. We'll divide that by 2, and we have 13. We'll keep on going down here. So we'll say we know that we have Jocelyn and M, Michael. So it's going to be 8 plus 14 divided by 2. So it's going to be the same thing as what we got? Michael, yep, J and M, so it'll be 11. All right, and we got A and E. All right, A and E, and that's going to equal the same thing as J and E. All right, so that'd be 12. And we got A and S, which is going to be the same thing as J, and S would be 13. All right, then we'll go M, and we got Michael and Erica. And so we have 14 plus 16. We'll divide that by 2. It's going to give us 15 is going to be the average age. Then we'll have Michael and Sarah. And with that, we're going to have 14. And you're probably maybe doing this a little faster, but I'm just filling this out as we go through. Make it fast forward this if you want. And then finally, we're going to have Erica and Sarah. And so we have 16 plus 18. We'll divide that by 2, and we got 17. All right, and we can see those. Now we're going to create a sampling distribution. Now a sampling distribution is of the sample means, and so this is going to be the average, okay, of the ages. Okay, and we'll start over here at going 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. And in doing so, we're going to put in this value. So we have an 8, and then we have 11. We have a 12, and a 13, and an 11, and a 12, and a 13, and a 15. All right, and a 16, and then a 17. Okay, of these different sizes. And so we have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have those. All right, so that's our sampling distribution. And in doing this, okay, what is the mean of the sampling distribution of the sample mean? So what is the mean of the sample distribution of the sample mean? Okay, and so if we look at that, and we look at the, so if we take all those different values and we look at that and we look at our mean, I'm guessing if we took all those different values and we add them together, all right, of our sample means, and we divide by, well, how many we have? 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And our sample mean, all right, so our mean of our sample is 12.8. And if we go up here and we see what the mean of the population is, all right, population, and we'll go up here and we take all these different ages. We have 8 plus 14 plus 16 plus 18. All right, and we divide that by 5. We have 12.8 as well. Oh, wow, that's crazy. All right, and so is the sample mean an unbiased estimator, all right, of the population mean? Now, when we talk about unbiased estimator, all right, that means is it the same? Is it the same? And the answer is yes, right? It um, the sample mean, the sample mean is unbiased estimator, all right, because uh, this one right here equals the actual mean itself, which are both equal to 12.8. If they weren't equal, then it would be biased as there is a difference between the actual population and the sampling distribution itself. And that's what we know there. And so now suppose we had taken samples of 3 instead of size 2. Would the variability of the sampling distribution of the sample mean be larger, smaller, or about the same? Now, when you increase, all right, when you increase the sample size, okay, what do we know? Whenever you increase sample size, variability decreases. So if we take samples of size 3 instead of size 2, we would increase it would decrease the variability of the sampling distribution. Of the sample distribution of the sample mean. All right, and that's what we know. Okay, and so right here, what we're going through is we found out how to create a sampling distribution, okay, by taking all of the possible combinations of our certain samples of these different ages. And as we do this, we realize that if we have a sampling distribution, we notice that the sample mean of the sampling distribution is actually equal to the population mean. And when that occurs, we know we have a unbiased estimator because these two values are equal. And if you want to decrease the variability, so these are going to be tighter together to what actually the mean is, we know it's going to be 12.8, so somewhere around here, we would increase the sample size. That a smaller decrease would create greater variability in values we're finding. All right, well, I hope this helps you out, and good luck and God bless in the rest of your problems.